Hello everyone. I'm standing outside my house to the side of it because I'm going to talk about on this video some bathroom vent fans. And the reason why I came over here is because right up here in the soffit that you can see behind me, yeah, see that hole right there? Well, that's how all this started. When my house was built, I didn't specify, specifically how the contractor should do the bathroom vent fans. So they hooked up some hose from each vent fan, brought it over here to the soffit, and then put a little, like a louvered vent terminal on the end of it. And well, that was 13 years ago, and I was out here one day and I noticed those vent terminals were really just like decayed, and they were brittle and broken and falling down, and I was ending up with just like some of them fell down. They just had a hole up there and stuff. And then so I set out to just replace those vent terminals, but in the process I discovered a bunch of other stuff on my bathroom fans that really needed to be addressed. So I addressed those things too. So there's really 5 things that I'm going to go over in this video that I've done to kind of upgrade my bathroom vent fans. The first one is I replaced the vent terminals with a better one. Well, the second one is when I got into the attic and found out that some of the hoses were torn. So they were leaking into the attic and the hoses were pretty thin. So I've upgraded to a better hose. I also found that in many cases they had come loose from the vent terminal. So I've got some clamps that hold them on now. Then number 3, I've found that I needed to tune the backdraft damper in the vent fan, and I'll explain that to you in a minute. But that was needed in my case. So number 4, I did find some air leaks while I had the vent fans apart, so I wanted to seal those up. And then number 5, the last one, is one of my fans, the backdraft damper wouldn't work, and I'll explain why in a minute. But in that case, I had to put in a actuated damper. All right, so let's dive into these 5 things, and I'll show you how I improved and upgraded my bathroom vent fans. All right, so this is one of the vent terminals that was up there on the in the soffit. This, when it was brand new, it was white, but years of air pumping through them from the vent fans and just dirt and everything. So this thing's in terrible condition, and you can see it's just so brittle. Like, most of them were all broken. This one was actually in pretty good shape, so I thought I'd use it to demonstrate how brittle it was. So then there's also a really small lip here for hooking on your hose. I mean, it's probably 3/4 of an inch of a lip. It's not much. So that's a problem. So I wanted to get a more upgraded version of this. So let me show you what I got. So this is a vent terminal that I found on the internet. It's stainless steel. It is round. It looks a little different. It does have a little screen in there so the bugs and critters and whatnot can't get up inside of the vents. It has a much taller collar also for attaching the hose. I will say this thing, these little louvers are like razor sharp. So handle these with care. I cut my finger on one of these. So it is just stainless steel, and I gave some thought of, running this thing through my sandblaster and then just shooting a coat of white paint on it, and probably would look better. But I just decided to just go with the stainless steel look. I mean, it's up in the soffits, and you can't really see it that good anyway in most cases unless you're looking up there looking for it. But most importantly, 13 years from now, I'm not going to be replacing this because it's steel, so it's going to last a long, long time. So in terms of hose, this is the hose that was up in my attic. It's just like a vinyl. It's very thin plastic. It does have like a wire round in the inside though. But in my attic, I found 2 different spots where this was torn open, and there was air just coming directly into the attic because this was torn open. So I wanted something better than this. Since I knew the one was torn, I had to replace it. So I got something something I think is going to last longer. So this is what I got as a replacement. So it is it's multi-layer, so it's like aluminum foil on the inside. Then it's, I think, 3 or 4 layers on the outside of like polymer coating. So I mean, it's thicker than the other thing. It's not as good as like rigid sheet metal duct would be, um, but I don't want to run rigid sheet metal duct down to all those soffits. So this is what I bought, and it worked pretty good. So in addition to the better hose, I also got a bunch of these. So these are actually like hose clamps. They're designed for that 4-inch diameter um, hose. This way I can clamp it really good onto the vent terminal and really good onto the vent fan. Because like I said, several of mine, the hose had come loose from the vent terminal and was just laying there. So I wanted some good way to attach it, and I figured this would be a really good, solid way that'll last for a long time. So hopefully I'm just fixing this one time. So I'm turning these where the louvers face toward the house, so any wind gusts that do happen, you know, won't be directed right in there. Okay, so I'm going to talk for a second about the bathroom fans and the backdraft dampers. See, and I thought a way to do this would be to show it on my house plan. So this is the floor plan to my house right here. So um, and the area that we're going to look at is going to be these bathrooms right here. And this is where the bathroom fans are. This is the electric plan for my house. So it shows, you know, lights and outlets and switches and stuff like that. It also shows the exhaust fans. So in our house, you know, we have 2 bedrooms right here and here. These are our children's bedrooms. And in between those two, there are 2 half baths, if you will, and then like a shower room. And so each of our kids have got their own like little bathroom with a toilet and a sink. Um, that's their own private, and then there's doors from both of those going into a little area, another little bathroom with a bathtub shower. So so there ends up being 3 exhaust fans in here, one in each of the toilet rooms and one in the shower room. And what happens in this case is a bit of a phenomenon with the HVAC system, and that's what I wanted to explain to you. So the backdraft damper that is like a little valve inside of the exhaust fan, the purpose of that backdraft damper is to keep, you know, like wind blowing from outside that blows in that vent and blows through that duct, and it could blow through the fan and into your house. So like if it's cold weather, the wind's blowing hard, you may be like, you know, heating your house and everything, but then cold air is going to blow right in, right? So the backdraft damper is like a check valve. So it closes if air blows in from the outside, but if the vent fan comes on, it opens, right? So the problem that I ran into is that the HVAC system can open that check valve and blow, you know, climate controlled air out, even when the exhaust fan is off. So I want to show you this view to show you where the fans are. And then I'm going to show you the the HVAC plan to show you where the vent terminals are. Okay, so you can see there's a vent terminal for the air conditioning system in each of these bathrooms, and then there's one in here in the shower room also. So if the doors are all open, it all works perfect, and the pressure generated by the HVAC system does not open that backdraft valve. But the problem is, in my house, if you shut these doors, which is often the case, and in fact, um, in our house, these two doors here to this shower room stay closed almost all the time. So, because it's the space between our kids' bathrooms, so they want their doors shut, and so they have the privacy, right? So this room, this space right here, is like almost always both these doors are closed. And with both those doors closed and air pumping out at 20 CFM into this vent terminal right here, that air has to escape underneath the crack of the door to get all the way back to the nearest return air duct, which is down here. So there's not a really good path, okay, when the doors are closed. That air being pumped out that vent, that's climate controlled or air conditioned air, has got to push under that vent or push under the door to get back to the return air duct. And so what happens is those rooms, and these too, if these doors are closed, which is sometimes the case also. So these rooms can become pressurized by the air conditioning system, and the air conditioning system, that little bit of pressure they generate is enough to open that little backdraft damper valve. That's supposed to only open when the vent fan's on. So what happens when that valve opens? You take your climate controlled air conditioned air that you're paying to generate, either heated or cooled, and you send it right out the a duct to the outside. So I actually detected this by accident while I was working on this system. I found I was up there and pulled some of the vent in the attic. I was up in the attic and I pulled some of the vents hoses loose, and then cold air was like blowing out, and I was like, "Whoa, what the heck's going on?" And then I realized that's what's happening. So with the doors open, it did not do it, but in our case, those doors are often closed. So that's why I wanted to tune the backdraft dampers, and by tuning them, I just wanted to put a weight on them so that they close better. And what I did is I weighted them so that they closed for sure, and the pressure generated by the air conditioning system with those doors closed did not open it, but the pressure generated by the exhaust fan when it's on does open it. So that's the tuning of the backdraft dampers I'm talking about. All right, so I want to show you this up close. This is this little square part snaps on to the sheet metal part of the fan, and like every bathroom fan is going to be different. Mine are Air King, but so there's a couple of snaps here and here that I just cut this because I'm throwing this away anyway, and then I just went in with this little tool here and kind of went in here like this and was able to pop this out of the sheet metal. But you can really see how this how this thing works. So let's looks like they did tape this pretty good. Let's talk about this flapper for a second. So this is the inside where the fan is, and what there is, there's this little flapper. It's on a little hinge, and the idea with this thing is that actually goes like this. If when the fan blows, it pushes it open like that. You can see it. I'm not holding it quite level, but it is supposed to want to shut itself. And then when the wind from outside blows, it pushes here and it stays closed. And if you look in there, you can see that the hinge points are up a little high, so they're like not exactly halfway up. And this one actually is not working that good, because look, I pushed it in like that, it's not even wanting to close. Some of the other ones were a little better than this. But what I'm going to do is I'm going to put a little weight right here, which will make this thing want to close. The reason why is because when the AC's on inside, it'll push that on, and it'll push your air-conditioned air right out the vent tube. So this just snaps in. You got to be real careful not to break these little tabs, but I snapped it out, and I'll tell you what I saw online is that there's some people who said that they put a weight on this. So somebody said they tape a penny onto it or something. So I'm not going to tape a weight on. I'm going to actually drill a little hole and put a nut and a bolt there, which will make the bottom of this thing a little heavier. So I had these already. This is a little stainless steel screw and a nut. It's actually an oddball size. I don't even remember what I got them for. They're actually it's actually an M5 metric size, but I happen to have it. It's a good like kind of short length, and I think it works good for this weighting application. All right. I didn't do that great of a job of centering it, but I think that's okay. Okay, so let's take a look now. So you notice now if it gets opened, that the weight of that screw is definitely going to close it. And the good thing is that pressure holding this down is going to help keep this thing closed, and the pressure from the air conditioner is not going to open it. And it'll still keep any wind blowing in. these cracks on this one are not as bad as some of the other ones, but these cracks are around the drywall are potential leak areas, and then there's these slots in the housing, and there's like a metal piece on the other side there, and there's one over here too. Anyway, so those slots lead directly into the attic too. So all I'm going to do is caulk up this crack and put some tape over those slots. I think that'll just help it a little bit. This does make a little bit of a mess, but there's kind of a raw edge all the way around here, which is hard to seal around. So I just been taking a utility knife and just kind of trimming all that off. I know it was a small gap, but I cleaned that up and caulked it. And then as you can see, I've got some tape over those openings there. Well, it's not perfect. There's still going to be some leaks out of this thing, but we've improved it a little bit. So I did want to show you this just briefly. Here's in the master bath. You can see that the fan is up there. The vent fan, and that bathroom has vaulted ceilings, and the vent fan is at an angle. So it's at an angle like this, and then the hose comes off of it and goes down to the soffit. So that valve, that flapper valve in there, because the fan's not setting horizontal, it just doesn't work, and it's never worked. Whenever the wind blows, we could hear that thing kind of tapping and making noise in there. It's been that way ever since we've lived in the house. I can't believe I've waited this long to fix it. What I decided to do was put in a damper, and this is what I bought. Let me show you this thing. This is a electric driven damper. So if you look on the inside, you see it's closed, and then it's got this little motor right here, and you power this thing and the damper opens. You actually can get these either way. You can get them that when you power them they open, and then when they're not powered they're closed. Or you can get them, in fact the way this one was shipped is when you power it, it closes, and when you don't power it, it opens. And you can convert it. It's very easy to I just unmounted this and mounted it to the other side. So these can be converted. This was kind of expensive. I think this was about $120. So this is a little more complicated solution. But since I'm getting into all these, fixing all these fans, I really wanted to do it right. To power this thing, what I did is I fished a piece of Romex wire up from the soffit all the way to where that vent fan is, and then I spliced it in so that it gets power whenever the vent fan is powered and running. And then on the end of that wire, I terminated it in a little junction box down there just inside the soffit. I'm going to mount a 24 volt AC transformer there, which is what this thing needs. So that way, whenever that fan is running, this thing will get its signal and it'll open. So I just wanted to set this up, kind of breadboard this for you to show you how it works. This is just a 24 volt AC transformer that I bought, and that's what I'm going to use. And then I'm just going to show you how this works when it gets powered. As you can see, it is quite slow. Had no idea it was going to be this slow. I would have thought it had been faster, but honestly, at the end of the day, I think it's fine. I don't think it hurts anything being slow to open like that. So, and then when power is removed, so you can see it's pretty simple, and once wired in and everything, it will be, you know, fully automated, and it'll open whenever the vent fan comes on and close when it goes off, and really you'll never even know that it's there. It'll just work, but it'll keep that wind from blowing back in. It'll also keep the air conditioner air from pushing out the backdraft damper. We'll talk about this for a moment. I suppose I could have just left this loose, sitting in there, you know, in the attic, but I'd really rather it be mounted. This right here rotates, and this right here rotates. I kind of want it to be fixed, so I'm going to just fabricate a couple little steel brackets. I found some pieces of galvanized steel that I have already, so I'm just going to cut those and shape a couple little brackets. That way I could just screw this with some brackets into the side of the joist up there, and so I'm going to do that next. This is a trick I use all the time. Set this thing on 1/2 inch and just scribe, you know, run along the edge of that. I don't know how well it'll come up on the video, but you can see you've got some scribed lines. So I've got 2 holes exactly 1/2 inch from the edge. All right, so I got our mounting flanges. So those are just self-drilling screws. You know, don't worry about those poking into the duct. I mean, ducts are full of screws pointing in like that. So now I'll just mount this. I kind of did it this way some. That way it didn't interfere with, the screws didn't interfere with the damper. And when I go to mount it, airflow is going to be out this way, so this will be easier for me to get to screw these into the joist also. So just wanted to show this. So here's the transformer. It's mounted on the cover of the junction box. This is the Romex that goes up to the fan. So then there's some wire on the secondary of the transformer, sending the 24 volt AC signal over to the damper, and that's where I mounted it there. And hook up the hose to this and it'll be all set. Alright, so after finishing the whole project and putting in the new vent terminals on my bathroom fans and stuff, I really wanted to update my my drawing package. So I've got drawings of my house. I have my whole house modeled in 3D on Autodesk Revit, and then I've got drawing views that are all generated from it. I did it years and years ago when I designed the house, but as I make changes to the house or define a few things better, I do go back and I update my CAD model because it's useful for me to use it in the future if I wanted to. So so I'll show you here. You know, 3 bathroom fans over here on this end of the house. The master bath has got 2, the guest bath, and then there's 3 fans over here in the kids' bathroom. And I just, you know, pointed out where those vent terminals are located, how the lines are routed in the attic. And since I was creating a ventilation drawing, I called this particular sheet a ventilation plan. I went ahead and showed where the dryer vents are, because I never really drew that up either. That was never in the original plan for the house. I just kind of figured that out while I was building it. So I showed that duct work for the dryer on the main floor, and then I've got a dryer on the basement floor too, right here, and where that is routed. And then I've got a duct right here that runs through the crawl space where I can bring fresh air into my safe room here. So anyway, thought I'd show this to you as a way to close and kind of show the project as a whole. So, hey, thanks for watching my video. Hey, I hope this is useful to you, maybe informational, and you learned a little bit about how bathroom vent fans work and how you can improve yours. Either way, thanks for watching, and I'll see you on the next video.